I do not have my mic and the wind is not great today, but we're going to try this anyways. So gravity can play a really big role in how tall structures or how big structures can get on different planets. So depending on the gravity environment. Because the more gravity you have, the more something is going to weigh. Literally, right? So we can see examples like Olympus Mons is really huge in comparison to anything that we've got here on Earth. But my favorite example is actually the Penitentes. So the Penitentes on Pluto. Now, that's a type of feature that we have here on Earth, but the ones that we have here on Earth are miniature in comparison. So what these are is they're basically ice spikes that stick right up into the sky. Like imagine sort of like a reverse icicle. They form from sublimation. So this is the state change when you go from a solid to a gas, right? Skip that liquid stage. It's not something that we're super familiar with other than with snow and ice in our daily life. But what will happen is you end up getting these spikes of ice that are sticking straight towards the sun. And here on Earth, they get to 1 to 2 meters, often smaller than that. Really cool looking though. The ones on Pluto though, there's so much less gravity there, and there's different kinds of ice, and Pluto's orbit is a bit different as well, more than a bit different as well. But what happens is that the ones that we found on Pluto are hundreds of meters. So we're talking skyscraper tall penitentes, these spikes towering into the sky. And that's because partly of the lower gravity. And there's some other places in the solar system where we suspect they might be, but we're going to need higher resolution images. We're going to need to go back and look at these places in more detail.